I'm about to show you how to save some time when you integrate the problem that you're about to see below. You might normally think that integration by parts is the only method here, and there's nothing wrong with that, but there's actually a faster way to solve this. When taking the integral of 1 over the square root of x plus 1 dx, you can start with the u-substitution method. You simply create a variable u, and you assign it to x plus 1, and then for this equation on each side, you take the derivative with respect to the variable you see. So the derivative of u would be du, with respect to u, and for x plus 1, it's simply dx. When you plug everything back in, this now becomes a simpler integral because it's simply 1 over square root of u du. Before I go on, leave a comment below and tell me what the next step is that you would do. And if you haven't already, hit that subscribe button, like the video if you like what you see here, and also turn on that bell notification so you don't miss my future videos. When I see a problem like this, the next really important step you want to look at is realizing this is actually a polynomial integration. Remember that 1 over the square root of u is the same as u to the negative 1/2 power. And this becomes very easy now because remember when you take the derivative of x squared or integrate it, we're always changing the power of x or u in this case by 1. To make progress then, what you want to realize is, remember, whatever the parent function we're trying to get happens to have a power of u that's going to be 1 more than what we started with, because it's when you take the derivative where you subtract by 1, but here we're integrating. So if we have a negative 1/2 power right now, 1 more of that is going to be negative 1/2 plus 1. And I like to make the denominators both be the same. So 1 is the same as 2 over 2. And when you add this together, we now know that whatever our final answer is, has a power of the variable raised to the 1/2. So this leaves us with a final answer of something u to the 1/2 plus c. And that's something, I'm going to call it a variable k here. You don't have to do this. I like to do it visually, especially if you've been struggling with these kind of problems. What I like to tell myself is, okay, in the original integral, nothing was in front of this u variable. But when looking at k here, if I were to go backwards now and get to the original integral problem, I would take the derivative of u to the 1/2, right? And remember that if you take the derivative of a polynomial, you are bringing that original power as a constant in front of your equation. So in other words, we know that 1/2 times k must equal what we started with, which was just a 1 in front of u. So if 1/2 times k must be 1, this leads us to find that k is actually 2. So our final answer is going to have a 2 here in front of u. And don't forget then to finally substitute back in what we called u, which is going to be your x plus 1 term. And there you have it. The final answer is simply 2 times the square root of x plus 1, all plus a constant c.